Squares now, which is in 1.3 on quadratic equations. This is a way so that you never have to use the quadratic formula if you choose to not want to use the quadratic formula. So let's take a look here. I look at this problem and I go, two numbers that multiply to give me 3, that add to give me -5. It's not possible. So my only options here are quadratic formula, right? Well, what else is there? Well, there's also called completing the squares, and here's what you do to complete the squares. To complete the squares, when you don't want to use the quadratic formula, you need to get all the x's on one side and just the regular old numbers. And that's what I did. Notice I moved this over, so it's -3 on this side and all the x's on the other. The formula for completing the squares is b over 2 squared. So you take whatever your b is. In this case, it's a -5. And you divide it by 2, and you square it. So b over 2 squared. So that actually becomes, when you distribute that through, a 25 over 4. But whatever you do to one side, remember, you need to do it to the other. So what we're doing is we're doing this negative b over 2, or sorry, not negative, just b over 2 squared, and we're adding it to both sides. So when we do that, that becomes a 25 over 4. And this is why you do completing the squares. You do completing the squares because whatever your b is, that b over 2, right, in this case -5 over 2, that becomes your factor. So it's x minus 5 over 2. So this helps you figure out what your factor is. You are writing this problem so that it can be factored now. That's basically what you're doing. So the point is, by you doing, oh, it's -5 over 2, it's x minus 5 over 2, and you square it. -5 squared is 25, 2 squared is 4. So the reason you did this is now you know what the factors are, and we could just square root everything to get an answer. So you combined your like terms over here. I write it as over 1. So I make it as over 4, which means I have to multiply the top by 4. So I actually have a -12 over 4 plus 25 over 4. And this is x minus 5 over 2 squared. Okay, because the formula is b over 2 squared. And that b over 2 is your factor. That's the best part about doing completing the squares. So -12 plus 25, that is 13 over 4. So it's x minus 5 over 2 squared equals 13 over 4. So now that we have that, to solve this, you just need to square root both sides. So I square root both sides. And now I have an x minus 5 over 2. And it's plus or minus. Remember, whenever you square root, it's plus or minus. And it is 13 over 4. So I add 5 over 2 to both sides to get x by itself. And here is my answer, except I need to simplify this if I can, which I actually can, right? I can rewrite this root 13 over 4 as root 13 over root 4, and root 4 is 2. And if I wanted to, I can combine those together and make it under one item, which is just 2. So 5 plus or minus root 13 over 2. So you could do, if you wanted to, you could do the quadratic formula and you would get the same exact answer, or you could complete the squares and not even worry about the quadratic formula at all, and just complete the squares. They both work the same.
Why make trillions?
We'll do example 6 there. Quadratic formula works for any quadratic that exists, period. Does not matter what it is. Works for any of them. -b plus or minus the square root of b squared minus 4ac divided by 2a. It doesn't matter what it is. It doesn't matter. It'll work for any quadratic. So example 7, we're going to use the quadratic formula to solve. So there's a, 1 is b, and that will be c for -3. So you just plug in everything. That's all this is. If you remember the quadratic formula, all you need to do is plug them in. That's it. So we have -b, so that's -1 plus or minus the square root of 1 squared, because it's b, minus 4 times a is 4 times c is negative 3 all over 2a, which is 4. Negative 1 plus or minus 1 squared is 1. Negative 4 times negative 3 is 48 over 8. 1 plus 48 is 49. So when you square root that 49, it's actually 7. So negative 1 plus or minus 7 over 8. So negative 1 plus 7 and negative 1 minus 7. Right? That's what that plus or minus means for those of you that don't. That means you split it into 2, right? Plus or minus is now it's minus and now it's plus. So negative 1 minus 7 is negative 8 over 8, which is negative 1. Negative 1 plus 7 is 6, and 6 over 8 reduces to 3/4. So your two answers are negative 1 and 3/4.
I got a bad feeling about this.
Okay. So taking a look at this problem here in example 8, right? This 2x, I'm just going to distribute it through here. 2x times 3 is 6x. 2x times negative x is negative 2x squared. I like to have positives, but you don't have to. So here's a good example where you don't have to have a positive to do the quadratic formula. So I'm looking at a 6x minus 2x squared minus 3. It needs to be in order. You can't just flop things down and say, okay, put it in the quadratic formula. For the quadratic formula to work, it needs to be in order from squareds, then x's, then numbers. So I need to rewrite this and put it into standard form. So there's my problem in standard form. That's your a, which is negative 2. My b is now 6. My c is a negative 3. So when I plug this in, my b is 6, so I put a 6 there and there. My a is negative 2, so I put a negative 2 there and there. And my c is negative 3. So all you're doing is substitution. Negative 6, so that becomes a negative 6. 6 squared is 36. Negative 4 times negative 2 times negative 3 is negative 24. 2 times negative 2 is negative 4. So 36 minus 24, that's a 12. So let's try to simplify this. The square root of 12 I can split up into root 4 and root 3. Right, because 4 times 3 is 12. Square root of 4 is 2. So I have negative 6 plus or minus 2 root 3 over negative 4. And now I can divide a 2 out of each of those. So when I divide a 2 out of each of those, I get a negative 3 plus or minus root 3 over negative 2. And your answers, if you wanted to, because I have a negative on the top and the bottom, I just pulled that out. I would accept this answer. It really doesn't matter if you pull the negative out and you just flip those two. This is fine right here if you just want to keep your answer like that. So hopefully when we come back here, we can finish up some more stuff on quadratics in 1.3 and solving them using completing the squares, quadratic formula, factoring, anything that you would like.